Hello everyone, welcome to my class. In today's class I am going to cover sum and difference trig identities. So let me start the class right away. First, the sum and difference identities for sine functions. Here alpha is angle and beta is angle. So the sine of sum of angles alpha plus beta turns out to be sine alpha cosine beta plus cosine alpha sine beta. So here the functions sine and cosine, they alternate, but this sine remains as it is. Similarly, sine of difference of angles alpha minus beta turns out to be sine alpha times cosine beta minus cosine alpha times sine beta. Again, the sine here is a minus, remains as it is. Only the functions between sine and cosine, they alternate here. Sine alpha cosine beta, cosine alpha sine beta. Great. We can combine these two identities together, which turns out to be here the third line, sine of angle alpha plus minus beta equals to sine alpha cosine beta plus minus cosine alpha sine beta. Great. Now let's move on. Similarly, the sum and difference identities for cosine functions. That's better. So cosine of sum of angles alpha plus beta turns out to be cosine alpha cosine beta, and then we alternate the sign from plus to minus, sine alpha times sine beta. So here functions repeats, cosine cosine, sine sine, but the signs plus to minus, signs alternates. Awesome. Similarly, the cosine of difference of angles alpha minus beta turns out to be cosine alpha cosine beta plus sine alpha sine beta. We can combine these two identities together. So here the cosine functions repeats, sine functions repeats, but this sine plus minus alternates to minus plus. Great. I hope this makes sense to you all. Now let's move on. Similarly, the sum and difference identities for tangent functions. Similarly, the sum and difference identities for tangent functions. The tangent of sum of angles alpha plus beta turns out to be tan alpha plus tan beta over 1 minus tan alpha times tan beta. So here this sign plus remains as it is on the numerator, but it alternates in the denominator. Here the sign plus remains as it is in the numerator, but changes plus to minus in the denominator. Similarly, the tangent of difference of angles alpha minus beta turns out to be tan alpha minus tan beta all over 1 plus tan alpha times tan beta. We can combine these two identities together in the third line here. Tan of alpha plus minus beta turns out to be tan alpha plus minus tan beta all over 1 minus plus tan alpha times tan beta. Here signs match in the numerator, this plus minus plus minus. If you have plus here, if you have minus here, minus there. But signs alternate in the denominator. I hope it makes sense to you all. Now let's move on. Quick alert. The angles alpha and beta are not the angles in the same triangle, and this is not true. Sine of alpha plus minus beta is not equals to sine alpha plus minus sine beta. And similarly for the cosine functions case, similarly for the tangent function case. Great. Next, the cofunction identities. Sine by half minus theta turns out to be cosine theta. I verified quickly in this note here. Let me go to the note and I'll come back for the remaining functions later. So here, sine by half minus theta, let's apply sine of angle alpha minus beta formula. Then by this formula, sine alpha minus beta, this formula, the middle one, which turns out to be sine alpha cosine beta minus cosine alpha sine beta. Now in the below example, we have alpha is pi half, beta is theta. So now here, so here, this is alpha, this is beta. So then by that formula, this turns out to be sine pi half times cosine theta, then minus cosine pi half times sine theta. And we know in the next step, sine pi half is 1, cosine pi half is 0. So then the second term disappears, so only we have first term, which is cosine theta. Hence, the first cofunction identity, sine pi half minus theta equals to cosine theta. Similarly, it turns out that cosine pi half minus theta equals to sine theta, tan pi half minus theta equals to cotangent theta, cosecant pi half minus theta turns out to be secant theta, secant pi half minus theta turns out to be cosecant theta, and cotangent pi half minus theta turns out to be tan theta. Awesome. Now let's move on. Quick recall the algebraic skill, the special product formula. A minus b times a plus b turns out to be a square minus b square. Perfect square formula. A plus b outside is square turns out to be a square plus 2ab plus b square. And a minus b outside is square turns out to be a square minus 2ab plus b square. You can combine terms and fractions using LCD. Here, a over b plus c over d turns out to be, here the LCD is BD, so AD plus BC over BD. Similarly, if you have a minus sign here, that is a over b minus c over d, it turns out that AD minus BC over BD. BD is the LCD in these fractions. I hope this algebraic skill makes sense to you all. Now let's review trigonometric functions value between 0 to pi at special angles. So here 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 120 degree, 135 degree, 150 degree, 180 degree. Similarly 3 pi over 2, 270 degree. And these are the functions sine t, cosine t, and tan t. And we know sine 0 is 0, sine 30 degree is 1/2, sine 45 degrees 1 over radical 2, sine 60 degrees radical 3 over 2, sine 90 degrees 1. And for the cosine functions, for the cosine 0 degree, just now I'm going to this direction, so 1. For cosine 30 degree is radical 3 over 2, sine 45 and cosine 45 turns out the same. Similarly, cosine 60 degree turns out to be 1/2, and cosine 90 degree turns out to be 0. Similarly, we can find out these other values also. And for the tangent, we just use the ratio identity here. Tangent t equals to sine t over cosine t, and you can find this value immediately. I hope you are familiar with this table. Great. Now let's do some example. Example 1. Find the exact value of the given expressions. Part A through D. Let's do part A. Let's find the value of sine 105 degree. We can rewrite 105 degree equals to 60 degree plus 45 degree, and we use the formula for the sine of the sum of the angles. So we know sine alpha plus beta. Let me show you the formula here. Sine alpha plus beta here is sine alpha cosine beta plus cosine alpha sine beta. The functions sine and cosine alternate, this sine plus sine remains as it is. So let me scroll down. So here, so sine 60 degree plus 45 degree turns out to be sine 60 degree times cosine 45 degree plus remains as it is, and cosine 60 degree times sine 45 degree. Now let's plug the value of sine 60 degree and cosine 45 degree from this table. So here we know sine 60 degree is radical 3 over 2, cosine 45 degree is 1 over radical 2. In the second term, cosine 60 degree is 1/2, and sine 45 degree is 1 over radical 2. So with those values, we have these expressions here. I hope this makes sense to you all. Then in the next step, we'll combine these two fractions by taking LCD. Here LCD turns out to be 2 times radical 2. So 2 times radical 2, 2 times radical 2. So then we simply add the numerator. So radical 3 plus 1. In the next step, to get rid of the radical in denominator, let's multiply by radical 2 in numerator as well as in the denominator. Then the last step here, we foil this radical 2 inside. So this is radical 6 plus radical 2 all over. The denominator is radical 2 times radical 2 is 2. Then 2 times that number 2 is 4. So that's our final answer. Great. I hope this makes sense to you all. Now let's move on. Part B. Evaluate cosine of pi fourth minus pi third. Apply the formula, the difference formula. The cosine pi fourth minus pi third turns out to be cosine pi fourth times cosine pi third, the signs alternate, plus sine pi fourth times sine pi third. We know the cosine pi fourth is 1 over radical 2, cosine pi third is radical 3 over 2, plus as it is, sine pi fourth is 1 over radical 2, and sine pi third is radical 3 over 2. I hope these values make sense to you all. These values are from the table above. Then add these two fractions, take LCD. So LCD turns out to be 2 times radical 2. Then we have simply adding the numerator. So radical 3 plus radical 3 turns out to be 2 times radical 3. 2 cancel out. So in the next step, we have radical 3 over radical 2. Again, we avoid radical numbers in denominator. So multiply top and bottom by radical 2 in the next step and simplify. It turns out that radical 6 over 2 our final answer. I hope this computation makes sense to you all. Now let's move on. Let's find the value of these fractions. Now this is the tangent functions formula for the difference angle. So then this turns out to be in the next step, tangent of 11 pi over 21 minus 4 pi over 21. That's the formula. Again, let me scroll up and show the formula here. For the tangent, so this right hand side is given to us, minus in the numerator, plus in the denominator. Then this equals to the left hand side here, tan alpha minus beta. Let me scroll down. I hope this makes sense to you here. So here, so minus in the numerator, plus in the denominator. So our formula is then tangent of the difference of angles. Then we can simplify these fractions. So 21 LCD, 11 pi minus 4 pi is 7 pi. We can cancel 7 and 21. So next step, it turns out that tan of pi third, and we know tan pi third is radical 3 from this table. Let me show you the table again. So here, tan pi third is radical 3. I hope this makes sense to you all. Now let me scroll down. Oh, here. Great. Similarly, let's do part D. Let's find the exact value of tan of negative pi over 12. Then we can rewrite negative pi over 12 equals to difference of these two, pi fourth minus pi third. It turns out that minus pi over 12. We can verify quickly. If you combine these two fractions, take LCD. Here's 4 times 3 is 12 LCD. Then multiply here 3 pi, multiply here 4 pi, but there is a minus sign, so it gives you minus pi over 12. Awesome. Then again by formula, this is the formula in part C here. I'm going left to right, right to left. This turns out that this is the formula. You know tan pi fourth is 1 minus as it is, tan pi third is radical 3 over 1 plus as it is, then pi fourth, tan pi fourth is 1, tan pi third is radical 3. Simplify, it gives you 1 minus radical 3 over 1 plus radical 3. We can multiply by the conjugate of denominator to get rid of the radical from the denominator. Great. Now let's move on. Now let's do example 2. Given alpha and beta are acute angles with cosine alpha equals to 8 over 17 and secant beta equals to 25 over 7. Compute A through C. So part A, compute sine of alpha plus beta. Part B, compute cosine of alpha minus beta. Part C, compute tangent of alpha plus beta. I hope the questions make sense to you all. Now let's begin the solutions. So first for given alpha, the cosine alpha is given. Let's find the value of sine alpha and tangent alpha. Similarly, for angle beta, secant beta is given to us. So let's find the value of sine beta, cosine beta, and tangent beta. Then we can easily find the value of those trigonometric functions here. Great. So here for alpha, so given to us cosine alpha equals to 8 over 17. We know cosine alpha equals to, in right angle triangle, base over hypotenuse, so b over 8. Then using Pythagorean identity, we can find the value of p. It turns out that p is 15. Then we can easily find the value of sine alpha and tangent alpha. Let me scroll this way. Yep, that's better. So sine alpha is the ratio of perpendicular over hypotenuse. So p is 15, hypotenuse is 17. So sine alpha is 15 over 17. Similarly, tangent alpha is the ratio of perpendicular over base, the p over b. P is 15, b is 8, so tan alpha turns out to be 15 over 8. Similarly, let's work for angle beta. We have given secant beta equals to 25 over 7. This is given to us. So secant beta is 1 over cosine beta, that is hypotenuse over base. So h is 25, base is 7. Then again using Pythagorean identity, we can find the value of perpendicular p, which turns out that p equals to 24. I hope this computation makes sense to you all. So now sine beta, the sine beta is the ratio of perpendicular over hypotenuse. So here p is 24 over h is 25. So sine beta is 24 over 25. Similarly, cosine beta is just the reciprocal of secant beta, so 7 over 25. And tangent beta is the perpendicular over base. Perpendicular is 24 over base is 7. So I hope those values make sense to you all. Now let me scroll this way. Maybe that's better. Yeah. So now let's answer the questions. So part A, compute sine alpha plus beta. By formula, sine of alpha plus beta turns out to be sine alpha cosine beta plus cosine alpha sine beta. So here the sine and cosine alternate, but this plus sign remains as it is. So then let's plug the value. Sine alpha is 15 over 17. Cosine beta from here 7 over 25. I use different colors so that it makes sense to you all. And then this plus as it is. Cosine alpha. Cosine alpha is given to us, which is 8 over 17. So 8 over 17 here. 8 over 17. sine beta is 24 over 25 here. Then let's combine these two fractions. We take LCD. LCD is 17 times 25. That means we simply multiply these terms in the numerator and add them. So 15 times 7 plus 8 times 24. And it turns out that the final answer is 297 over 425 for part A. I hope this computation makes sense to you all. Now let's move on. Now let's do part B. Compute the value of cosine alpha minus beta. Use formula. Cosine alpha minus beta turns out to be cosine alpha cosine beta plus sine alpha sine beta. The functions repeats and the sine minus becomes plus. I hope this idea makes sense to you all. Then let's plug the value here. So cosine alpha, this is the value given to us, 8 over 17. And cosine beta, we found cosine beta here, 7 over 25 plus sine alpha is 15 over 17, and sine beta, we found sine beta is 24 over 25. Let me scroll down and again combine these two fractions by taking LCD and simplify. It turns out to be the final answer is 416 over 425. I hope this computation makes sense to you all. Now let's do part C. Compute tangent of alpha plus beta. We know the formula of tangent of the sum of the angles equals to this plus sign remains as it is in the numerator, but in the denominator the sign changes. So we have tangent alpha plus beta equals to tan alpha plus tan beta all over 1 minus tan alpha times tan beta. Now let's plug the value. So tan alpha is 15 over 8, tan beta is 24 over 7, 1 minus as it is, tan alpha is 15 over 8 and tan beta is 24 over 7. Now in my numerators we have a fractions, in our denominator we have a fraction, so combine separately. Let's combine first fraction in the numerator. Again LCD is 8 times 7 56, so multiply 15 times 7 plus 24 times 8, so this is the fraction in the numerator. Similarly let's combine the fraction in the denominator. By the way, we have 1 over 1, so the LCD turns out to be 8 times 7 56, so 56 times 1 is 56 and minus 15 times 24. So we have this fraction denominator, and we can cancel this 56, then we can add this 2 terms in numerator, subtract these 2 terms in denominator and simplify. Our final answer turns out to be minus 297 over 304. I hope this algebra makes sense to you all. Now let's move on. Example 3. Use sum and difference formulas to verify the trig identities. So let's verify the following trig identities. Part A. Given trig identity is sine of x plus pi fourth equals to radical 2 over 2 times sine x plus cosine x. Let's begin the solutions. Start from left hand side. Copy the left hand side as it is. Then apply the formula for sum of the angles for sine functions. So sine of x plus pi fourth equals to sine x times cosine pi fourth plus cosine x sine pi fourth. Here the sine and cosine alternate, but this plus sign remains as it is. Then we know the value of cosine pi fourth is 1 over radical 2, sine pi fourth is 1 over radical 2. In the next step, we can factor the 1 over radical 2 outside, so we have 1 over radical 2 times sine x plus cosine x. We want to get rid of radical number in denominator, so let's multiply by radical 2 on numerator and denominator. Then it turns out that on my numerator is radical 2, on my denominator is radical 2 times radical 2 is simply 2, and sin x plus cosine x as it is. This is right hand side, hence we verified this trig identity. Great. So now let's move on. Part B. Let's verify this trig identity. Cosine of 3t equals to 4 times cosine cube t minus 3 times cosine t. Now begin the solutions. We know this formula, cosine of alpha plus beta equals to cosine alpha cosine beta minus sine alpha times sine beta. The functions repeat, cosine cosine sine sine, but this signs alternates plus to minus. Now let's replace alpha by 2t and beta by t. Then we have this star formula here. And by the way, this cosine of 2t plus t is cosine 3t. So I'm substituting this star in left hand side here. And also we know this formula, cosine of 2t is cosine of t plus t equals to cosine square t minus sine square t. Again, this value comes from immediately from this formula here. If you replace alpha by t and beta by t, then we have on right hand side cosine square t minus sine square t. Similarly, in the sum formula for sine functions, if you apply alpha equals to t and beta equals to t, then sine alpha plus beta turns out to be sine t plus t, turns out to be sine 2t. Then the sine 2t turns out to be 2 times sine t cosine t. I hope this formula makes sense to you all. Now let's start from star here. So cosine 3t equals to cosine 2t plus t here. And then now right hand side of star, cosine of angle 2t is cosine square t minus sine square t times this cosine t as it is here, minus as it is, let me scroll down, sine of angle 2t is equals to 2 times sine t cosine t, which I wrote down here, and this sine t is as it is here. I hope this idea makes sense to you all. Now let me scroll down. That's better. Now let's FOIL here. So cosine t times cosine square t is cosine cube t minus sine square t times cosine t is sine square t cosine t, minus as it is. Then send the sine t inside, so this becomes 2 times sine square t times cosine t. Now we can combine this second and third terms. So I copy the first term as it is, then minus, this is 3 times sine square t cosine t. In the next step, I copy the cosine cube t as it is, and we know the formula of sine square t equals to 1 minus cosine square t. That's from Pythagorean identity. And then in the next step, cosine cube t as it is, then send this negative 3 cosine t inside the parenthesis. Then negative 3 cosine t times 1 is negative 3 cosine t, minus times minus is plus 3 cosine t times cosine square t equals to 3 cosine cube t. All of our trig function is in cosine forms here because our right hand side is all in cosine form. So in the last line, now let's combine 3 cosine cube t and cosine cube t, the first term and then the third terms. Then we will get the final answer 4 times cosine cube t minus 3 times cosine t. This is the right hand side, hence we verified this trig identity. Great. So we finished these sections. Thank you.